we're still humans. We're still a physical world, because at the end of the day, I got to move from my house to work. I got to go to see the clients. I got to go on vacation. I still have a physical machine that I have to engage with in some way, which means a value creating company has to create something and ship it.
It's the engineer's own fault, like the bold statement, to actually feed that system with his implicit and explicit knowledge, to feed it, to train it, and then wondering why he has been substituted. Do you think this becomes a problem?
Companies have to choose either to replace someone or they have to choose to not hire. And if you look at the deployment of automation, the people who were fearful of their jobs were thinking a robot's going to replace my job. And we're seeing humanoid robots get out there and do things that humans do, but only better, right?
Jim, welcome to the show again for like the 10th time.
Yeah, thanks, Yusuf. Appreciate it. Yeah, these are fun.
Yeah, absolutely. Today we'll talk about agentic engineering, a very hot topic, and physics-informed neural networks, a word that I haven't heard for like a couple of months. So we'll talk about like your insights into pins and agentic engineering, but also the T-shaped engineer, so what that means for the job market.
Yeah.
But before we jump into that, people who haven't listened to the other 9 podcasts between you and me, who is Jim to begin with?
Yeah, thank you, Yusuf. Yeah, I'm a mechanical engineer turned entrepreneur. So we are a channel partner of Ansys. So we're connected to Synopsys, which is now probably the 10th or 11th largest software company in the world. And so what we do is support our customers mainly in the simulation and analysis field, which includes, of course, the mechanical engineering simulation capabilities, as well as electrical, optical, et cetera. So what a wonderful time to be in simulation. I keep telling everybody it is changing every day, and I love it. And I'm super excited about this particular topic.
Absolutely. Maybe small, I wouldn't call it anecdote, but like maybe a timeline of how software evolved over the last years. We had software 1.0. I think every engineer remembers when you actually had to type in code into your computer or your machine, sometimes even punch cards back in the days, right?
Yeah.
FEA back in the days. And then we had the revolutionary paper on AlexNet around a couple of years ago. It was not too long ago. There was software 2.0 where you actually had weights and biases, basically predicting things. And then we have software 3.0, which is large language models, which means we can, with natural language input, create cool stuff, code, whatever, CAD models even nowadays, and all sorts of things.
Yep.
And the cool thing about this is the adoption actually of software 3.0 is that the masses, the people first adopt 3.0 first, and basically then the large corporations come and then adopt it. So it's really nice to see kind of the transition and the shift in how people use AI.
Yeah.
It has some pros and cons. So we'll talk about agentic engineering, Jim, now, and what it means for the engineer and the job market of engineers. When we talk about agentic engineering, everybody thinks now it's great. We talk about physics, AI, and all that great stuff. But what does it concretely mean for all these engineers out there? Anyway, without that out of the way,
yeah,
stage is yours.
Well, yeah. I mean, first off, great sort of quick historical, sort of flashback there. I have this conversation. I have conversations on this topic pretty much daily now, whether it's with Corey inside here at Fastway or with all of our software partners or our customers. Listen, for me, this is actually a little bit of a deja vu. Okay, I don't know anyone who's been in simulation. Okay, about 25 years ago, right, which is when I was entering the job market. Okay. I would say that I would have been at the forefront of trying to use simulation. I was a believer. I was, I didn't know what I didn't know. And so I believed it and I wanted to use it everywhere. And, when you're 20 something and you're out there trying to tell all of your coworkers who have 25 years experience, let alone life on this planet, trying to tell them, hey, you're doing it wrong. Or, hey, there's a better way. Okay. Hey, there's a faster way. Of course, it's accurate, right? And we're having the same conversations right now. I mean, let's think about it, right? Like, let's say a kid fresh out of a mechanical engineering degree program, okay, bachelor's, goes in, works at a large manufacturer. Let's just say a major OEM, defense, medical, automotive, whatever. Okay. And they say, listen, guys, you gotta have an AI right next to you. You can't be Googling things anymore. It takes too long and you got to sift through it, and who knows if you're going to get good stuff. And by the way, like if you are actually using a mouse, and a GUI, like you're just not slow. There's a faster way. Okay. And we're having these same conversations like as we did 20 something years ago. We've got people who are sort of believers, and maybe they don't have enough experience to know where sort of the faults could lie, right? Maybe have that judgment, that keen eye on whether a physics informed neural network or any AI or predictive tool is going to give them an answer that didn't get there through physics, right? Through proven math and proven scientific equations. And that's fine because they're going to push it forward. But at the end of the day, like, we have to check ourselves, right? So the first step, right? There's a couple different steps as we start to deploy AI, right, into engineering workflows. The first step here is what we're seeing right now, which is agentic. And most major software platforms are providing an agent, a co-pilot, some sort of informed sort of interface. And in the background, it's being trained with all of the same information that you have access to. Okay, so if I'm sitting here and I'm doing FEA and I'm building a model and I'm using a code that requires a GUI, right? I'm importing CAD. It's a native environment, and on the right hand side, I've got an agent. What am I using that agent for? Every single time I have to guess. Every single time I can't find a button. Every single time I think to myself, well, this doesn't look right. Okay. And that is going to do one of two things. One is it going to potentially replace the person you have been asking, right? Maybe it's your coworker down the hall, or nowadays, if you're working hybrid or from home, you're asking somebody, some trusted resource, right? So now it's going to be a little bit faster. It may or may not be more accurate, but over time, it's just going to be accurate, straight up. Like, we're not going to be questioning the results out of agents in a year or two, right? I mean, it's being fed by the same data that technical support engineers or whomever is going to be, whoever has experience, giving you that same answer.
Yeah,
you're getting an answer that's going to be accurate. It's going to be fast, and it's just going to enable you to do better, do more work. And people who haven't trusted or aren't trusting that tools yet, they may be earlier in that simulation sort of journey. And so they might be asking the agent questions that they wouldn't ask, and they would just guess. Pre-agent, they would just guess something and move forward. So the impact is immediate, but it's low-hanging fruit. Let's be honest. Like, it's low-hanging fruit. These are like tech support questions. These are, how do I do this? How do I make myself incrementally better? I mean, if an engineer saves him or herself 5 minutes, is that going to change the stock price of a company anytime soon? No, it's not. So we're seeing agents being deployed, but it's just picking up sort of the low hanging fruit right now. It's not like massively going to change any companies or anything like that.
Do you think so? Like, I mean, maybe another question. I mean, we have the physics-informed neural networks, which are grounded into the conservation laws, right? So obviously they have to obey some sort of physical laws. With large language models, especially in the beginning, as we saw, they're very bad at mathematics, right? So the question is, how do you merge something like large language models, something like software 3.0, as we mentioned earlier on, plus pins, and make the best out of it for engineering applications?
Yeah, I mean, loaded question, right? So if AI version 1 is agentic for technical support, which is what we're seeing right now, okay, the next step is agentic to build the model. Let's be honest, right? Like, what's the next bottleneck in the whole situation? Well, it's onboarding new users. And so now we're going to get agents in the front end. We got agents in the back end. Now we're going to get agents in the front end, right? So what's the third piece of the puzzle, Yusuf? An agent in the middle, or AI in the middle, right? I got AI providing tech support. That's the low hanging fruit. Okay, we're always going to need tech support engineers because someone's going to have doubt on something they're doing. Okay, and then we've been automating the setup of models ever since the beginning, right? First, it was really easy because we had to write code to build the model, and you can easily loop that in some do while or iterative loop. And now you've automated the front end. We've kind of gone away from automation. We went to like GUI and keyboard and mouse interaction to these interactive, but we've got other value. And now we're going back to automations with Python APIs and scripts and things, right? And so AI can write a Python script faster than you can read the book, right? And so the third piece of that puzzle is sticking AI in the middle. And so now that's where we get that physics-informed neural network, right? I mean, at the end of the day, neural networks don't solve the physics problems, right? They're not solving Hooke's law for FEA. They're not solving RANDs, right, for CFD. But they are bound by the laws, right? Conservation of mass, let's say. And there's that loss function that gets fed back in, right? And that's going to control in the same way that we check residuals in a CFD model. It's checking, hey, what's our difference between one side of the equation equaling the other side of the equation, right? Are all my F's equaling all of my MAs, if you will, right? And of course, with CFD in particular, USIP, which is an area I know you spend a lot of time in, as do I, we've got the closure problem with turbulence. And that's why I think we're seeing the number one application, at least from what I see of pins right now, is CFD, because it's going to help accelerate and close and minimize errors in the closure problem of turbulence. At the end of the day, right? Like whether I'm using a K omega or I'm using a neural network, okay? If I got to find, all the shear forces, the viscous shear forces, I'm going to go find them. And all I have to do is get enough data sets to train it. And so we're going to build our trust pretty quickly. Now, those who are deep into multi-phase phase change, hypersonic, some really, really extreme, say, fluid applications, and those that have high risk if we get it wrong, those are going to take a little while, right? But electronics cooling, I'm sorry, but we got that more or less figured out, right? I mean, you've got applications there where, first off, the risk isn't necessarily, in the scheme of things, is not that high, and the complexity of the turbulence isn't that high. Reynolds number's not that high, half electronics cooling's laminar. If you look at it, if you design it right. So we're starting to see the implementation of AI in the middle, in between the two agents, if that makes sense. That's what I'm saying anyways.
Okay, what shift would that cause in the job market, for example, or the skills that engineers need to acquire right now to be very quick and to be irreplaceable, in air quotes?
I think is it
even something that you can avoid?
The impact to the engineering labor market. I think that is the question that a lot of people have, right? Anyone who thinks, a lot of people are really tuned into macro effects and socioeconomical and geopolitical, environments, and that, if you spend enough time looking at that, you're going to get a little fearful of, hey, what's coming around the corner tomorrow, next month, next year. And those people are probably a little fearful AI. Put it on the list, okay? One of those things that is going to impact the job market. How? $1 million question. And I think this topic had popped up. A friend of mine is an accountant, okay? And so we had this conversation. We've had this conversation going now for I think a few weeks or months, which is there's been a shift in accounting, financial, right, legal, right. ChatGPT just came out of nowhere, right? Here you have this trained LLM and is able to do the work of, I don't know, given a certain agency or a given firm, you just replaced interns, right? You took a chunk of your team, okay, and said, where could I just start replacing people? Because how can I scale better, let's say? Or in the case of some financial markets, they might peak with activity, say one time a year, right, during taxes, or every 3 months, say at the end of the quarter when it's a publicly traded company and you have to publish your results, right? So there's these waves of financial activity, and which is just crunching numbers and creating documents, and those documents have to meet some semantic requirements. And ChatGPT and the GPT tools came out and just replaced so many, I would say, again, low-hanging fruit. I'm going to probably use that term too much here, but people who were just there to create text based on the combinations and analysis of others, the synthesis of other analysis. That's AI. ChatGPT can do that all day. And the catch with these large language models, right? They're replacing quality with quantity. I think that's what a lot of people don't understand is it's mathematical statistics, okay? Mm-hmm. It's okay if I don't know everything. Back to the math world for a second. It's okay if I don't know all the variables going into an equation. I can flood that with a Monte Carlo analysis. I can flood that with a DOE. I can put a lot of what if scenarios through the stuff I don't know, and I can figure out through a sensitivity study if it's whether I need to know it or not. So all these things I don't know, I can kind of statistically remove and isolate the things I do. Back in the LLM world, that's basically what it did. It ranked the web pages. It ranked the quality of the writing and said, all writing that I'm going to output is going to meet the highest quality. And so my friend's like, how do I get ahead of that? And he's creating some really cool apps with Claude Code, and he's kind of staying at the forefront for himself. But the question becomes, what does that mean for us in engineering, right? What does that mean for those of us who are, we are assigned to a job where we operate within the rules of physics, some better than others,
Yeah,
and LLMs can't do that.
yeah, would you still
Pins,
say
pins
like
can.
we reduce the amount of workforce anyway? Because, for example, let's take a low-code tool, right? There's a lot of low-code tools out there that engineers use.
Yeah.
To some extent, it's the engineer's own fault, like the bold statement, to actually feed that system with his knowledge, with his implicit and explicit knowledge, to feed it, to train it,
Yeah.
and then wondering why he has been substituted. Do you think this becomes a problem?
Well, I think the step one is where do we think? Companies have to choose either to replace someone or they have to choose to not hire. And if you look at the deployment of automation, okay, if we use the skilled labor market for a second in, say, automotive, right? So vehicle assembly, okay, the people who were fearful of their jobs were thinking a robot's going to replace my job, right? And we're seeing humanoid robots get out there and do things that humans do, but only better, right? But a good robot, okay, a good automation solution is designed to do one or two, three things really, really good, right? Those robots don't look like humans. So when automation came out, it wasn't a matter of replacing all of the labor on the assembly line with humanoid robots, because that hasn't happened, right? And you wouldn't do that. Like, if you're going to automate an entire process, why is it designed for a human in the first place? Why would there need to be a humanoid robot involved? So automation went out at single points, right? And said, hey, this particular part of the process is going to get replaced by an automated machine. And Toyota famously said, and this is in the automotive market again, Toyota famously said that they're never going to fully automate. Why? Because robots don't make themselves better. Humans do. It's part of their Kaizen, right? That Toyota quality management process that has been sort of, picked up by a lot of other companies and industries. Well, we do have some robotics that are picking up some, with AI that can kind of predict and be better, right? But they're going to be stuck on their physical limitations. Take that back into engineering now, okay? So now in engineering, what's the first thing that's going to get replaced? It's the repetitive tasks. So again, what's repetitive task, low-hanging fruit, things that we can just crunch down, technical support, and building the model in the first place. Hence, agents, agentic, right? Where you're sitting there building models and doing your job, right? And then as we start to fill the middle with AI, you got to ask yourself, one, if you're a dedicated analyst, you got to ask yourself, okay, how am I going to work alongside AI? And the answer to that is just like the engineer on the floor, who you've got one person who manages 3 CNC machines or 5 CNC machines, right? Whereas before it was 3 people per 1 CNC machine, one person to load, one person to program and babysit, another person to unload and swap out. But now you've got one person who's managing 4 or 5 machines. So now you're going to have one person managing 4 or 5 or 6 sims all at the same time, all at various states of prep, solve, post, etc. And some are doing that even now without AI, but the complexity of the models is going to go up, right? It's going to go from single physics to multi-physics. So one person can juggle 5, 6, 7, 8, 9, 10 sims at a time, and they're all going to be multi-physics. And it's because they're going to be using AI for prep, post, and then ultimately at some point solve. And once you put AI into solving, it's not even 10, it's like 100 or 1,000 sims at a time, right?
That actually puts the productivity of this AI champion inside of an organization like at the very, very top. So the question becomes, how can I make sure that I become one of those AI champions? Like, because time is running out. It feels like time is running out, right? So
time is running out, I think, is a fallacy, right? I
think so.
We're all in control here of the speed of deployment, whether it's at the company the industry level, company level, team, personal level, right?
Yeah.
Like I don't fear for my job. I don't fear for FEA software suppliers or distributors or supporters in any way, right?
Mm-hmm.
For every, I'll say, low-level physics, so every single physics, okay, we're going to have an AI that can solve that problem 10 times faster. It still needs to get fed with data. The biggest challenge that many manufacturers have today, and even more so in the supply chain, tier 1, tier 2, is they don't have the data to train. So who how are they getting data to train a neural network so that it can be 80, 90+% accurate, so they can get the answer they get in 10 seconds is actually something they can use. And the answer to that is traditional FEA, CFD, all of our traditional simulation capabilities. That data is sound, right? We're at the point now where we can build any single physics model should be within 5% error, right? Mm-hmm. There's not a lot of single physics simulation going on nowadays that is going to create more than a few points of error, because those tools are mature and they've been proven to meet all the applications. Multi-physics, maybe a few points less now, but that's going away. Fully coupled physics, the fact that, we've got more and more academics and in industry using these tools and validating them for us. So bottleneck now, core, trustworthy simulation data to feed AI, so that the AI tools can actually be trained with decent data and give you a reliable solution.
What is actually nowadays, and I think, Jim, you know that better than I do, what is nowadays possible using agentic AI? I mean, we talked about like the whole documentation thing, upskilling thing, when we just tap into the documentation of a specific piece of software.
Yeah.
But like what's already, I see a lot of stuff on LinkedIn where people actually just automatically build CAD models. That, for example, already is a huge shift from like me having to do it manually. When I think back when I use Pro Engineer, for example, it took me like, I don't know, 20 hours to build something.
Yeah.
To now going down to minutes, which is crazy. So how do you have some applications in mind, or maybe some use cases that you can talk about and maybe have seen?
So CAD is interesting, okay? And CAD has its own challenges versus the simulation sort of arena. So in the geometry world, right, our language, if you will, is how to represent a boundary, okay, right? We use the term BREP to signify a watertight volumetric model, something that can be meshed, something that can be CNC machined, something that can go into 3D printing, right? So how do we create that BREP, right? If anyone wants to, they can open up, for example, a STEP or an IGES file, right? STEP and IGES are controlled semantics, right? So you open up with a text file, right? So that starts to look a little bit like ChatGPT in a way, only because if you rip it open, you're looking at points, vertices, edges, surfaces, volumes, okay? And then there's metadata in there as well, because we use some of those files with PDM systems, right? So revision control, ownership, history, et cetera, et cetera. So we already have a basis for using agents to create CAD, because we're describing CAD with ASCII text, okay? So I think where the OEMs, right, so PTC, right, which was Pro Engineer back in the day, that was the first CAD tool I learned as well, but their Creo tool, their web-based Onshape tool, which is really, really interesting, right? It's a SaaS solution. Autodesk has a SaaS solution and a local solution, right, with Inventor and AutoCAD versus Fusion, Dassault, Siemens, right, NX, CATIA, et cetera, et cetera. SolidWorks, of course, right? So all of those are using some proprietary, we're using proprietary or not kernels, right? Some of them use Parasolid. Those kernels are going to be tucked behind, say, some binary file. So they're going to own sort of the agentic creation of that CAD. But there's got to be some sort of cross-talk, if you will, and leave it to the entrepreneurial market. I'm sure there's going to be an AI tool. I think there's a couple out now. Can't think of any names off the top of my head, that you can feed in a STEP and IGES file, and the AI is going to reverse engineer it and give you design intent. Because we want design intent. We want a pattern of holes. We don't want a bunch of cylinders, right? Like, we want to understand that those are holes and there's a pattern, et cetera, et cetera. So there are agentic CAD tools out there now. I think it would be like, I don't know, for maturity, maybe like a level 4 or something like that, where it's proven. Pockets of academia, I'm sure industry is working on it as well. But no one in a production sense that I know of yet is going out there and just using an agent to create that geometry. I think the reason is that it has to continuously be vetted for quality, right? Production CAD that goes into a production process downstream for work instructions and machining and assembly, that is IP, and that can't be wrong, right? We have to have nominal geometry and we have to have tolerances. I'm not quite sure agentic CAD is at the point where it's in full production. If somebody's watching this and they hit the comments and say that I'm wrong, then that'd be really exciting, because I could learn as well. But In the CAD world, I think they're still trying to understand how to use it alongside the language of CAD that we know today. Simulation, on the other hand, all simulation is written by ASCII code, right? So we already had the language, right? Like there's a language that exists. So to create an agent, to create an FEA model, the CFD model, the infrastructure was already there. The console in Fluent never went away. The scripting language from Ansys and Nastran, it's still around, still ASCII text.
What would be the long-term vision? I think it's relatively straightforward, right? I mean, building the CAD, setting up the simulation, boundary conditions, simulation parameters, etc., then running the simulation and then post-processing it seems straightforward for an agent or like an orchestration or like agent swarms to do that. Have you seen anything like that, like at Ansys?
Well, I mean, there are some AI tools right now, some SaaS-based AI tools. SimAI comes to mind. And it can be fed with a variety of data, right? So it can be fed with field data, it can be fed with simulation data, I would urge anyone who's listening to this to go take a peek at what's out there. I can't speak to exactly what's going on under the hood, but all FEA, CFD, CAE tools, all the companies they have an AI solution. So, they're working on it. Let's put it that way. And if I were them, and we kind of have one foot in it, you're just targeting a market. It's like the new FEA tool. Where did the first FEA tools get deployed? Where did Nastran first get deployed? Trying to go to the moon, trying to get up into space. The hardest problems that are the most expensive, the ones that you really can't get wrong the first time, the ones that really, like, there is no such thing as iterating necessarily when you're trying to get something on the other side of the solar system. So, you got to get it right the first time. And so how do we handle large problems? Sometimes we have to create new tools along the way. And that's right. That's like sort of the foundation of the simulation industry is we're going out there to solve really hard problems. So AI is out there to solve hard problems that people have to do again and again and again and again and again. And it's expensive to test, and it's still pretty expensive to simulate. And even with GPU solving right in CFD, even with increased hardware capabilities, we're still doing a lot of simulation. External aerodynamics is the perfect application for pins because, again, we've got the closure problem with CFD. If we don't get shear forces right, we're not going to get drag and downforce right, and it's something that we can automate with CFD, build out 100, 200, 300 CFD models, go train an AI, and now we can do what ifs, in a couple seconds.
I'm maybe thinking 5 to 10 years into the future, Jim. I think that everybody is now betting, especially Anthropic, OpenAI, and all these other companies, they're betting, also Google, they're betting on solving AGI, which means they're providing us with tools that are relatively cheap because we don't really know what a token costs. Like I haven't read any. I don't know from the top of my head. Maybe someone knows and can put it in the comments. I don't know how much a token actually costs because I think me paying €100 a month for Cloud Max is super cheap. So the question becomes: I think at some point there will be the discussion of having a token tax, most likely in place. Which, if we all deployed all our systems into agentic systems, could mean that we actually have to pay additional costs, which we try to save by firing people. Now we have to pay like a CO2 tax, but for tokens. So I'm not sure where that road is heading towards. I'm not sure if you have an opinion on that, but it could be that everybody's betting on it and like offering it us for basically free because we're training the systems and everybody's betting on solving AGI, which could also mean that in 5 to 10 years, hey, wait a second, you're not paying €100 a month anymore, $100, but like $1,000 or $2,000 a month, which is crazy.
Yeah.
So I'm not sure what that means for engineering as well, right? Because if you deploy all these systems to agentic systems and you use stuff like Anthropic systems, Claude, OpenAI, etc., what that means for engineering.
Okay. So first off, engineering isn't done in a vacuum. Okay. If I put my business hat on for a second, engineering's done inside of a business, inside of the P&L, okay, the profit and loss, right? Yeah. And if you look at a business and you look at I'll just say bottom up, low-hanging fruit to the highest value of employees, okay? AI is already coming into the business, okay? Engineering isn't first. We just talked about this, right? Where are you getting the first deployment of AI? HR, legal, okay, finance.
Yeah.
Right? You're getting the semantic aspect of business. You're getting your AI has been in it. AI has been in HR for years. You think you're getting pre-vetted when you're trying to get hired into a company. You're getting pre-vetted by a human. No. You've been talking to bots for years on whether or not you're the right person for the role. That's just the top of the funnel for trying to find talent, right? So AI is now into those layers of the business. Okay, engineering is up here, right? You know who's at the top, by the way? And this is my opinion. You know who's at the top?
Tell
In a
me.
hardware manufacturing. I just gave it away. In a hardware manufacturing company, who's the last to get replaced by AI?
The one who's actually building the stuff.
Yeah, the physical aspect of it. Okay,
Yeah.
we're not eggs in a matrix. Okay,
Not yet.
but it's been proven, right? Like we're still humans. We're still a physical world, and that's why I'm a nuts and bolts guy. I'm a car guy. I'm a physical guy. Planes, trains, automobiles. Because at the end of the day, I got to move from my house to work. I got to go to see the clients. I got to go on vacation. I still have a physical machine, right, that I have to engage with in some way, which means a manufacturing company, a value creating company has to create something and ship it, right? Transportation, shipping, right? So if you look at the layers of the business, we're already sort of, I'll say, deploying AI or redesigning the efficiency of the people who work in finance, accounting, HR, legal, right? So we're starting now to get into the layer of the business that's engineering, okay? Just now, okay?
Mhm.
So as an engineer, we're starting to fill up the tank with AI, or it's gotten to us, and we're looking for different ways to engage with it. But you can't remove it completely, okay? Any company that tries to outsource engineering, and that's kind of the equivalent, right? Saying, hey, listen, we don't want to hire engineers. We're going to manufacture stuff. We just aren't going to hire any engineers. And then that's out there. Those are contract manufacturers. Those are CMs. They're out there, and they're all over the planet, right? But the engineering layer is never going to go away. There always needs to be. I mean, engineers. We're like firefighters. We're R&D. Engineering has such a full spectrum of applications, from the production and the fix it now and keep the lights running and make sure that we don't have any downtime and that all the machines are up, to the aspect of like, well, what are we going to do for R&D? And AI is just sort of penetrating and helping those people along the way. But I don't see the being replaced per se. It's just going to be a very similar sort of rollout like we saw in automation in the skilled labor market, which is there's going to be pockets of it, and those pockets of AI, those pockets of automation are going to be replacing the repetitive tasks, right? Or the tasks that are just relatively low impact in a business. That's kind of my assessment on it. I think that brings up the problem, which is I don't know if you've heard of this term before, right? But the senior junior inversion crisis. Have you heard of this before?
I can maybe guess what it is, but let me know like what it actually means.
So think about it like this: like if, for example, we do start replacing interns with AI, we're screwing our future selves. It's like
much.
fast forward 5 years, okay? What happens to that company that doesn't have the people with 5 years experience? Oh, they're hosed. Because what they didn't do is they didn't backfill. As people retire, right? As people are retiring out of the market, you're losing so much knowledge of that person. The smartest companies, I've been training FEA and CFD for 15 plus years, okay? The smartest companies, all right? And by the way, 15 plus years ago, when you go in to train FEA, there was like only a couple different personas that would show up in the room. The new kids would show up because they're like, oh, FEA, this is CFD, I want to learn the new tools. But the experienced guys wouldn't show up. And I would go to the manager and be like, you definitely want to get some of your professional, your senior engineers in this. Yeah, they don't want to learn it. I'm like, that's not why they need to be in this class. They need to be in this class to sit next to the young engineers so they can speak the same language. So the smartest companies in the world were deploying simulation so that the young engineers were doing simulation, but the older engineers could understand what they were doing. They brought all the experience, but somebody who had been in the industry for 20 years wasn't going to jump in FEA for the first time in their career. They just didn't want to, right? We have this, we're, engineers kind of get stuck in their ways, or they get successful doing something. So the smartest companies were bridging and creating these mentorship programs, right? Mentorship programs are so important, so important in engineering. You need a transfer of knowledge. It needs to happen in a very colloquial, in-person, sort of on-the-job way. And if AI comes in and starts replacing the first layer of the business because somebody looks at a P&L and says, where can we get more profitable? They're going to completely mess up that company in a couple of years, because now you're going to have this gap of talent between the experienced people who aren't working alongside the best tools, and then the people who don't have 5 years experience. And look at post-COVID, same thing. Post-COVID, we lost so much talent.
Fully agree. But that would actually motivate me as a business owner, for example, especially of like big companies, to actually start introducing things such as low code, which makes it very easy to capture and extract all the knowledge from all the old people who might retire in a couple of years. So therefore, either I have the decision to either only have AI champions, or like, well, engineers / agentic engineers, so to speak, if we want to call them agentic engineers, that just orchestrate the tools, so they're becoming more like an orchestrator, as I said.
Yeah.
Rather than just relying on this inversion curve. Yeah. Exactly.
Yeah. I mean, I think that regulated industries are going to move at a different pace, like they always have. I think that industries at the forefront with the most to gain, you're going to see some really kind of great, crazy, goofy stuff, right? And like consumer electronics, right? There's not too many rules there with consumer electronics. They can throw a sensor and a screen on anything, and we'll see how the consumers kind of interact with it, right? Making their home smart, making their office smart, making their body smart, right? So it's hard for me to say. We have customers in every single industry, from the fully regulated industries to the completely unregulated industries, and they're all using AI in some way or another. You could argue that some of the more regulated industries, the larger OEMs, have been using it for a really long time, just not in the form that we're seeing being sort of deployed right now. Yeah. Definitely not a SaaS model, right? We're not talking about trading a lot of information with the internet. A lot of it's behind the firewall, a lot of it's in back in there, but I mean, those OEMs have decades of data, so they can trust those tools, and they're using them. No one's using AI as the final say. They're using AI in the middle, where you want to do what if scenarios. You just want to accelerate that. So I don't know. I forgot your original question, to be honest. So I forgot where I was in that. But I mean ultimately.
Maybe one of the wrap-up. Sorry to interrupt, by the way, Jim.
Yeah.
One of the last questions I probably have is like maybe an outlook or like a roadmap. Maybe you have something in mind how agentic will be deployed in engineering and how it will shape the future of agentic engineers. And what we can do, by the way, maybe is also again a loaded question. So the future prediction, if you can make one, Jim, of where we're going to move in terms of engineering, but also what do we need to do as engineers now, maybe studying mechanical engineering, studying FEA, studying CFD, to become an agentic engineer as fast as possible, without losing touch with first principles?
Well, you always have to understand first principles, right? So that will always be a part of an accredited engineering program. You can't call yourself an engineer without learning engineering, physics, the math basis, the physics basis, and then from there branching into your first order, second order, linear, nonlinear equations for whatever discipline you want to get into, right? I think we're always going to have people who want to go a PhD route and publish and create and author things, and maybe those who want to stay in academia and continue to pull up the future generations. We're going to have people in the middle route at the master level who are going to say, hey, listen, bachelor's is a basis, bachelor's versus master's. That is my basis. Let me go get a master's. There's going to be a master's in AI. I haven't checked. I don't know if there's a program that's being offered right now, but there's going to be a master's in engineering AI. And what that because it's just a matter of time, right? Where you become a specialist in the application of first order principles and engineering principles and the math and science under the hood, but in its application in a particular discipline or industry. And that's a new role that is going to get created, and people are going to hire for it, right? Just imagine when all of a sudden we had simulation engineers. right? It's like, I want to go get a simulation degree. There's a simulation degree now, right? Cornell's got one, right? That's focused on Ansys, and I'm sure there's others that are out there that are focused on other codes, or even focused on open source codes, right? But we're creating these new roles, and those roles are where companies are going to try to deploy that AI first. But as time goes on, okay, when I graduated when I was in college, late 90s, early 2000s, and we were just getting FEA into the curriculum and into young engineers, it wasn't very well trusted. Now it's trusted everywhere. Simulation, FEA, CFD, we've proven it, okay? AI is now getting into it, right? So here we are, 25 years later. Now AI is getting into the curriculum. Kids are going to start playing with it in junior high. Kids are 3D printing stuff in high school. Kids are in CAD in high school. CAD has gotten all the way into pre-college, all the way down in. Simulation can't get that far down because you kind of need to know a little bit. But there is, right? There's these sort of conceptual, like F1 in schools, right? That's a high school program with CFD. The kids understand Navier-Stokes, maybe one of them or two of them do, most of them not necessarily, but they understand drag and downforce. So the tools are sliding down. AI is going to start to slide down. I think kids are getting introduced to AI outside of the engineering realm first, but certainly if I were a college professor right now, I would be scrambling to start updating some of the topics that I cover, because every single topic, statics 101, statics 102 is going to have AI at the end. How do I train neural network? Right? Like, okay, now that I know the first order equations of state, let's go train a neural network. And I think that's what I presume what all the students are wanting to know. Fast forward 5, 10, 15, the physical labor, we're seeing this in other industries. The physical labor market, the skilled labor market is going to continue to become very, very, very valuable, right? Because listen, if people get replaced by AI, or they switched companies and the new company doesn't have the same role that they have, they're going to maybe go into skilled labor, and those are going to be very well compensated areas. So I honestly don't know. We're going to see I think a rise in skilled labor, right? They're going to see a rise in AI degrees. What does that mean for the business? What does that mean for the P&L? Usually it starts off with a high profitability, followed by a recorrection, followed by maybe we went a little overboard. But I don't know. Simulation never really went overboard, right? I don't know. No company did too much simulation the last time I checked.
I don't think so. Is there anything else we might have missed, Jim, regarding the topic of agentic engineering or PINT?
Yeah, there's the whole like sort of generative optimization side, which is like the big dream that everyone's really going for, which is, well, now that we have a PIN, now that we have a neural network, now that we have a tool that can give us an answer really quickly, and we trust it, we've trained it, what do we do next? And I think that's where we're going to start to see some new technologies kind of blossom, right? Multi-physics, pushing the limits of physics, we're going to start to do at a completely different level. I think there's going to be some new technologies out there in the hardware world that are really in an area of, like, electromagnetic, thermal, structural, fluid, like in that hot, super hot, chemical kinetic reaction, like some super high tech stuff that you just can't get there without an AI, trained neural network. I don't know, nuclear, for example, right? There's a lot of nuclear technologies that could start coming out, for the better. So, yeah, we'll see. I don't know.
We'll see. We can discuss what happens with AI in the next podcast, which might be soon.
Yeah.
Any other topics that you want to talk about in the next podcast? Maybe some precursor of what we're going to talk about.
Well, the question is so a PIN, right? Physics informed neural network. That's one sort of implementation, but I think the holy grail would be a large physics model. So how do we get, instead of a large language model where the data set, the background data set is language, right? Say ASCII text in some form, is there ever going to be a publicly available, not behind the firewall, is there going to be a publicly available physics data set that we can start to interact with? The answer is yes, because there's some out there. But the next time we talk, which might be to say in a few months, it's changing very quickly right now. So I think that space is one to really watch and to see. There's a couple companies out there that are creating, right now, if you come up with a new Gemini, new Claude, right, there are benchmarks that they're testing against, speed and accuracy, right? And there's benchmarks being created right now for physics AI, sim AI, neural networks, large physics models, et cetera. Those benchmarks are being created now. So we're about 2, maybe 3, at most 5, but I don't think so, years behind where the chat GPTs are. But it's coming. It's going to be really exciting.
Absolutely. So we'll talk about that in one of the next podcasts, Jim.
Yeah,
it was an absolute pleasure as always.
Yeah, likewise, Yusuf. Yeah.
And see you in the next podcast.
Sounds good. All right, take care.